Alright, Unit 3, Learning Target 2c. I can graph piecewise functions. The plus next to the 2c just means that it's a plus standard. Plus standards are stuff that we'll actually talk about in pre-cal, but it's going right along with what we're doing in Algebra 2. So it's just a little bit of extra knowledge for you. We looked at a piecewise graph with the last learning target real briefly, but if you'll recall, it was a graph that had several different pieces of lines on it. So we'll look today about where those pieces come from and why they look the way they do. So in example 1, we've got two pieces. We've got negative 2x minus 1 if x is less than 1, and we've got x minus 3 if x is greater than or equal to 1. So before we go straight to the main graph and draw the pieces, we're going to graph the two lines separately and look at which pieces of those graphs we need, and then we'll add them to the main graph and see what our final graph looks like. So if we draw a graph for the first line, we know that we'll need to start down at -1 because our y-intercept is -1. So I'll put a dot right there. We know our slope is -2, so that means we're going to move down 2 and over 1. We could also move up 2 and left 1. And then we draw a line as best as we can to connect those dots. Alright, so that's what the graph would look like if we didn't have any more to it. If it just said -2x minus 1. But we only want this graph for x values that are less than 1. So I'm going to draw a vertical line that crosses right through -1. Now we only want things on the left side of that vertical line because we only want values of x less than 1. So we only want the graph on the left side. Try to remember too, if it's just less than, it's going to be an open circle. So this point right here should be an open circle. When we draw it on the main graph. So I'm going to draw exactly what I have with my open circle and only on the left side of 1. So that open circle happened down at, or over 1 and down 3. I would have an open circle. I crossed the y-axis at -1. So I'm going to go ahead and put a dot there. And we moved up 1, up 2, and left 1. So I'm going to draw that line that makes that graph that looks just like what we have on our other graph. Alright, so let's look at the second piece of that piecewise function. I'm going to do the exact same thing. I'm going to draw a graph. I'm going to graph the whole thing, and then we'll only look and see which piece do we need. So our y-intercept in this one is -3. So we'll go ahead and put a dot there. Our slope is 1, so that means we're going to move up 1, right 1, up 1, right 1, up 1, right 1. We could also move down 1, left 1. Then I'm going to draw a line connecting all of those dots. Again, I'm going to draw a vertical line at 1 because we know that we only want values, in this case, greater than or equal to 1. So, since it's greater than or equal to, I know that that is going to be a closed circle. So I'm going to come over to my main graph. I'm going to put a closed circle at that exact same spot, over 1, down 2. And I know my slope moves up 1, over 1, up 1, over 1. And we only want the graph on the right side. We only want it for numbers greater than or equal to 1. So this is what that final piecewise graph would look like. Because I'm writing in pen, I felt that it would maybe be beneficial to draw these two graphs separately and then redraw them on my main graph. If you're writing in pencil, then you can draw that whole graph and just erase the pieces that you don't need. So if you think that that might be easier, go ahead and feel free to do that. But again, since I'm writing in pen, I'm going to draw two separately and then copy it over just to make sure that I have it right. Alright, let's look at example 2. This one's got 3 pieces, so when I draw my graph, I should see 3 separate pieces of my line. So again, I'm going to come over here and I'm going to draw my graph for that first equation. I'm going to draw the whole thing, and then I'm going to copy it over on my other graph to see what it should look like. Alright, for the first piece where it says x plus 3, if x is less than or equal to negative 1, I know my y-intercept is at 3, so I'll put a dot there. My slope is 1, so I can move up 1, over 1. But I could also move down 1, left 1. And I've got a little bit more room to do that, so I'm going to do that a couple times. Then we'll connect those dots. Alright, so we want this line if x is less than or equal to negative 1. So I know I'm going to draw that vertical line again. I know I'm comparing it to that vertical line that I just drew. Since it's less than or equal to, we know we're going to have a closed dot at negative 1 where I drew that vertical line. And we only want the line less than 1. So that means we don't want any of this piece up here that I'm Xing out. So I'm going to copy that over on my graph, my main graph, that's going to have all of it, the exact same way. We're going to have a closed dot at 1, and we're going to move down 1 and left 1, down 1, left 1, and we're only going to the left. So that's what that piece looks like. 1 down, 2 to go. The next piece is x squared. Now that's that parabola shape, that U shape, and it looks something like that. And I know we haven't talked about the specifics of that graph, and we'll get to that shortly. But for right now, you need to know that if your x value was 1, and you said, what's 1 squared? You would say 1. So this graph goes right 1 and up 1. If your x value is 1, 1 squared is 1. So you'd be over 1, up 1. If your x value was negative 1, negative 1 squared is just 1. So again, if x was negative 1, y would be 1. So our graph a little more precisely would look like that, where it's crossing at the point 1, 1, and also at the point negative 1, 1. Alright, so with this second piece, we only want x that's less than 1 and x that's greater than negative 1. We want those pieces in between 1 and negative 1. So I've drawn my vertical lines. Again, if you're using pencil, you don't really have to think about, or you don't necessarily have to draw the vertical lines. You can just erase your graph that's not in between 1 and negative 1. Since there's no line underneath, we know that each of those circles are going to be open circles. And we don't want any of the graph outside of 1 and negative 1. So I drew some X's through there. So if I copied that down on my main graph, you know we're going to have an open circle at 1, 1, an open circle at negative 1, 1, and we've got that piece in the middle in between it. One more graph. Alright, so the last piece of that g of x function just is 4, just plain old 4. So try to remember, what's that line? G of x equals, g of x is just y. So what's y equals 4 look like? We would come up to 4 and draw a dot if you need to. And y equals 4 is just that straight horizontal line that goes all the way across and crosses through 4. Alright, we want 4 if x is greater than or equal to 1. So I'm going to draw that horizontal line that I've been doing straight up and down at 1. And I know that that's what I'm going to compare it to. I know that it's greater than or equal to. So since it's or equal to, we're going to be a closed dot. And greater than would only be on the right side of that dot. We don't want anything on the left side. So if I drew that line on my main graph, we want a closed dot at 1, 4. And we want that line everything to the right because we want it greater than or equal to 1. So that is what the graph of g of x would look like. Normally I would say any questions, and I'd probably get several of them because this isn't really simple stuff. It's not terrible, it's just a lot going on at once. So I'm guessing there'll probably be some questions. Please feel free to ask whenever you get in class, or if you're watching this in class, please make sure and pause the video wherever you get confused and somebody will come and help you. Thanks.